Hi all. Today we are going to learn about the higher level communication modes used in IoT. So in the previous classes we have learned about the basic architecture of IoT where there are sensors, actuators, microcontrollers. So all these components needs to communicate with each other. So IoT devices don't just talk, they are using different styles of conversation. Some whisper occasionally, like batch mode. Some shout alerts, which is called as event-driven mode, and some stream the data continuously like a live video. So we will learn the different higher level communication modes which is used in IoT-based systems. So these modes describe how the devices or components in an IoT system exchange data at the application level. So there are basically six communication modes available: request response mode, publish subscribe mode, streaming mode, event driven mode, command control mode, and batch mode. So let's first see the request response mode. So here the device sends a request and wait for a response from the server. For example, your mobile application or your mobile phone may be sending a request to a server, and the server is acknowledging that request and sending a response message back to the mobile application. So the typical hypertext transfer protocol HTTP or constraint application protocol COAP all are using request response mode for communication. So the use cases are it is usually used for configuration of devices, data retrieval, device queries, etc. So the key characteristics includes synchronous communication. That means the receiver should acknowledge the message and send back a response message. That is what is called a synchronous communication. And this request response model is simple and it is widely supported in IoT applications. Its advantages include it's easy to implement, it is reliable for small scale applications. Limitations include high latency as it needs to wait for the response from the receiver side, and it is not suitable for some real-time applications. In case of domain examples, it can be used for patient device request medical history from hospital servers. It can be used for smart homes where user requests the current temperature from a particular thermostat or a thermal sensor. In industry, the machines may request the configuration updates from a central server. All these use cases we can go for a request response model. So it is best to fit for applications like occasional queries are required, configuration needs to be established between devices or in diagnostic modes. The next one is publish subscribe mode. Here the device publishes some messages to a intermediate broker, and this broker will reroute the message to the subscriber which is intended to receive that particular message. So the publisher will publish some sort of messages to the subscribers, and there will be an intermediate broker. That broker will be rerouting the messages to each individual subscriber which is subscribed for that particular data. So here there are different protocols using publish subscribe mode. Example, MQTT, message queuing telemetry transport, and DDS, data distribution services. Usually it can be used in use cases like alerts, notifications, real-time updates, etc. Publish subscribe mode uses asynchronous communication. It decouples publishers and subscribers. Its advantages is it is scalable for large IoT systems and it is using efficient bandwidth usage. But the limitation includes it requires a separate broker infrastructure which is used for rerouting the packages to the concerned subscriber. And it is potentially complexity in managing the subscriptions. Examples can be like in smart cities, traffic sensors publish the condition data, whereas the app subscribe for the update from that sensor. In agricultural use case, the soil sensors publish some moisture levels, and the irrigation or the sprinklers may be the subscribers there. In industrial IoT, the machines may publish the status of some sensor things, and the monitoring dashboards will be act as the subscriber there. So this publish subscribe mode is best fit for alerts, notifications, scalable real-time updates, etc. The third mode is streaming mode. Here the data is continuously streamed or continuously sent between the device and application. So there will be some device, that device will be sending some data to a cloud server or some remote server, and that data is lively fetched by some device applications or services. So continuous transmission of data is happening in streaming mode. Usually it is used for WebSockets, gRPC streaming, etc. The use cases include telemetry, video feeds, real-time dashboards, etc. It is using a persistent connection. It is having low latency as the data is continuously streamed. There is no waiting time, so the latency is less. It is ideal for real-time monitoring and it supports multimedia data, that is audio, video or images can be sent. Its limitations include it requires high bandwidth and it requires a stable internet connectivity. Domain example includes in healthcare application the continuous ECG or heart rate monitors streaming patient vitals to hospital dashboards. In smart homes where the security camera are streaming the live video and feeds to mobile apps. In industry where the machine streaming vibration and temperature data is used for predictive maintenance. In smart cities where the traffic sensors stream the vehicle counts in the road and the condition levels are sent to the control systems. So this streaming mode is best fit for real-time monitoring, safety critical systems and in continuous analytics where instant decisions are required for generating alerts, automation, predictive maintenance, etc. The next mode is the event-driven mode. In this mode, the communication of the actions are triggered by a specific event or a condition. For example, in case of say smart door sensor or a smart door, when the door sensor is initiated at the same time, the mobile application will be sent from the sleep mode to the active mode. That means the device may get wake up at that point of time during that event trigger. What is the event trigger there? The initiation of door sensor. So during the initiation of door sensor, the device get wake up and it will send a message or alert to the end user. So whenever there is a threshold or some instant trigger, at that time only the communication will be taken place. Examples are MQTT return messages, COAP observe, constrained application protocol. COAP means constrained application protocol. And the use cases are it is used for sending alarms, it is used for fault detection, sending notifications, etc. The key characteristics include it is using reactive communication. Reactive communication means the communication is activated only when there is a trigger. The event trigger drives the system behavior. Advantages include it is very efficient and it reduces the unnecessary data transmission. The limitations include it requires accurate event detection. The sensor should be precise and accurate so that the event driven mode will work perfectly. And it may miss events if it is not properly configured. Domain examples include smart homes where a smoke, for example, in case of a fire or smoke is detected inside a home, that alarm will be triggered. In healthcare, if there is any of the threshold or body parameters are less than a value, an emergency alert will be sent to the doctor or a nurse. In industry, it is used for fault detection, and when a fault is detected in any of the machines, the system will be automatically went to shutdown mode. So it is best fit for alarms, fault detection, reactive systems, etc. The next one is command control board. Here there is a cloud or central system which sends commands and the devices will execute that commands. So the command will be sent by the central system or the central coordinator, which may be a microcontroller or a microprocessor, and the actions will be executed by the devices and the feedback will be sent back again to the central coordinator. Usually MQTT command and RESTful APIs are using this command control mode. So usually it is used in use cases where controlling the actuators in IoT application. It is used for smart appliances and also it is used in robotic applications. So the key characteristics include there is a centralized control done by a microcontroller or a microprocessor. It is used for direct device manipulation. The next one is the advantages of command control mode. It should be precise over devices and it is supporting automation and orchestration. Orchestration means it is controlling and coordinating all the components associated with the central coordinator device. Limitations include it is vulnerable to security breaches if the commands are intercepted by some intruder. It requires reliable connectivity throughout the work hours. Domain examples include smart homes where the cloud sends command to lock doors or turn off lights. In smart agriculture, the cloud commands irrigation pumps to start or stop when the soil moisture value is less. In industrial IoT application, the central system initiate commands to robotic arms in assembly lines. So this command control mode is best fit for actuator control, automation and in robotics. The next one is the batch mode. In batch mode, the devices periodically upload collected data in batches. So instead of sequentially streaming the data from the sender to the receiver, it will collect the data and store in some sort of buffers, and say a period of 30 minutes or in 1 hour, the collected data will be sent from the sender side to receiver. So it will not be continuously sequencing the data from the sender to the receiver. Instead that it will collect the data and process it as a single batch. So its advantages is it is working based on time based communication. So we can set the when to process the batch, like we can set a time for when to process the batch. It can be like 30 minutes, it can be like 1 hour, it can be a 1 day, like that. As we are processing the data communication in batch, it is more efficient, it is more energy efficient, and it can be used in low power devices. So this mode can be used in agriculture monitoring, environmental sensing, and periodic reporting. The advantages include it conserves bandwidth and energy, and it is suitable for non-real-time applications. Limitations include it is not suitable for urgent or real-time alerts, as it is sending the data only on batches. We cannot always collect the live values. So it is not suitable for real-time monitoring. And domain examples include in agricultural field, the sensors upload soil and weather data once per day. In environmental monitoring, the air quality sensors will send the daily reports of the carbon dioxide content and oxygen content in the atmosphere. In smart city applications, the energy meters upload consumption of energy data periodically, say once in a month or once in every 15 days, like that. So this batch mode is best fit for energy efficient periodic reporting and non-real-time applications. So let's summarize the different higher level communication modes. The request response model is actually simple, reliable, but it is having high latency. The publish subscribe model is scalable, asynchronous, and is ideal for applications where alerts can be generated. Streaming mode is usually used for continuous real-time data, but it requires heavy bandwidth. Event-driven mode is efficient, reactive, but it requires precise and accurate triggers initiated by the sensors or the central coordinate. Command control mode is centralized, powerful, but it is less secure. Batch mode is energy efficient, periodic, but it cannot be used for real-time or live streaming of data. So these are the various high-level communications modes used in IoT. Thank you.